Hello everyone, this class is BUS-AML 7247 Analytics for Macro Marketing Data. This video is for Lecture 8, Carryover Effects. In this lecture, we don't have any reading requirements. In this lecture, I'm going to introduce the ad-stack model, which is widely used model for ad effect analysis. Then I'm going to talk about lagged correlation coefficients and how to use the lagged variables in a regression model and how to interpret the lagged variables. It sometimes takes a long time from an ad to an conversion. Once a consumer watched an ad, she may search internet for more information about the product. She may consider other options instead of the product. And after that, she may purchase the product. This is just one possibility. Of course, there would be a person who purchased the product right after she watched the ad. Of course, there would be another person who don't purchase the product although she watched the ad. Anyway, once consumers are exposed to an ad, its effect is usually long-lasting. Ad-stack model is a widely used model to describe the long-lasting ad effect. It assumes ad-stack, which abstracts how response to advertising builds and decays over time. Exposure to an ad builds awareness in consumers' minds and influences their purchase decision. The details for the model is as follows. Sales or demands are a function of ad stock and other variables. And ad stock is a stock variable to keep ad efforts denoted AD over time. This stock is decaying over time because the awareness created by ad exposures will be higher if there have been recent exposures and lower if there have not been. This lambda is the decay parameter that controls for how long the ad effects are lasting. This is an example. Suppose the lambda is equal to 0.5, meaning that the ad stock decreases by half every time period if there were no ad spending. And from the first time period, suppose that there was unit amount of ad spending at every 10th time period. This is an example. Suppose the lambda is equal to 0.5, meaning that the ad stock decreases by half every time period if there were no ad spending. And from the first time period, suppose that there was unit amount of ad spending at every 10th time period. This table shows how ad stock variable is evolving over time. At time 1, there were ads and ad stock is generated. At time 2, the ad stock decreases by half because there were no ads. At time 3 and 4, the same thing happened. And at time 11, new ads were coming and ad stock is regenerated and it decays again. This figure shows how ad stock changes with different lambda values. The black curve is for 0.5 as in the table, and the red dashed curve is from 0.9 of lambda, and the green dotted curve is for 0.1 of lambda. If lambda is 0.1 or 0.5, the ad stock decays to almost 0 within 10 time periods, whereas if lambda is 0.9, the ad stock does not entirely decay within 10 time periods, so it shows a long-run increasing trend. If ad stock model is, or successfully describes the truth, we must observe that, obviously, sales are correlated to current ad spending, and sales are correlated to lagged ad spending as well. So, most advertising studies assume that ad stock mechanism or put the lagged advertising variables to measure the ad effect. In R, we can easily generate the lagged variable through a lag function. And value in the lag function set which lag will be returned. If n is equal to 1, the function returns the previous value. If n is 2, the function returns the value at 2 time points before the current time period. This is a log-log demand model for advertising. because zero ad spending is often observed. Just for explanation purpose, I put only 2 lagged variables into the regression, but the length of the lags could be much longer. And this is the estimation result. The details will be discussed in the next page. Here, I've replaced the estimated values for the Greek letters. This is log demand model, so the interpretation must be elasticity concept. That is, the coefficient estimates are elasticities, the percent changes of sales when the ad increases by 1%. So, the effect of 1% increase in ad on the current sales is 0.43% increase in sales, and the effect on the next sales is 0.17% increase in sales, and the effect of the sales at 2 points after current sales is 0.07% increase in sales. Thus, to measure the entire effect of an ad, all the effects must be accumulated. Alright, that's all I have for this lecture. In the exercise, you will revisit the quality perception and ad spending data. This time, you will see all forms in the original dataset. You are going to be asked to generate the lagged variables and put those lagged variables into the regression. Then, see you in the next lecture. Bye bye!